section 6, chapter 7, we're looking at solving by quadratic methods. So quadratic methods means that we can factor. It means that our equation here kind of looks something like a quadratic, right? It looks something like ax squared plus bx plus c equals 0. Or in the book they have a u instead of a variable. It doesn't really matter. So for instance, right, we have something being squared, and then plus that something times by a number, and then plus some kind of constant, right? And that's what we have here. We have something being squared, which is tangent, and then plus that something, tangent, and then minus a constant. So really you could do it two different ways. You could just solve this by factoring, or you can treat that tangent as an x or as a u, right? Just some variable. So then u squared would be tangent squared x. So this would just be u squared plus u minus 2 equals 0. Then we can just cab it, right? Factor, however you factor. So it's c times a is negative 2, adds up to b is 1, so that'd be a positive 2 times negative 1, and 2 minus 1 equals 1. So those are our two numbers. Then we divide by our a, right, which is 1, so that's not changing anything. So we get u plus 2 times u minus 1 equals 0. You can use the zero product property because it's multiplication of two different things, two binomials. So u plus 2 equals 0, and u minus 1 equals 0. So u equals negative 2, and u equals 1. Then we can substitute our u back in, which is tangent, right? So tangent of x equals negative 2, and tangent of x equals 1. So what angle gives us a negative 2 for tangent? And that one we don't know off the unit circle, right? So there we're going to have to use a calculator, right? So then we can do inverse in our calculator. So we can do tan inverse of negative 2 on our calculator. And it just depends on what you get. If it's our answer wants to be from 0 to 2 pi, so it wants it in radians, so then you put your calculator in radians. So you put your calculator in radians and you get x equals negative 1.1071487 approximately, right? And then tangent of 1, we already discussed this, right? That was at 45 degrees, so that's pi fourths. And at 5 pi fourths, because at 225 as well. So those are our answers for x right there. So those are our two answers. And then here, since we're in radians, here we can't have an answer between 0 and 2 pi of negative 1 point something, right? So that means, and what I said before, right, if I get an answer, which our answer is negative, so that means we're down somewhere right here. And I said, remember, 180 degrees away, or a pi away, is the same answer. So if I get an answer, say, of negative 2 here, I would also have an answer right here of negative 2. So if I add 180 or add pi to this, so if I add pi to this, I will get that positive angle, right? So if I add that, then I would get 2.0344439 approximately, right? Approximately. And then, since I'm now here, if I rotated another 180 degrees with another pi, I would get that same answer of negative 2, right? When I type in this new angle, right? So if I add another pi to this one, I will get my final answer. So this is one answer, this is one answer, these two are answers. If I add another pi to this one, or add 2 pi to that original negative 1.1, then I'll get my last answer, right? Because tangent and cotangent, 180 degrees away is the same answer. So this one's 5.1 something, 5.1760366, something like that. So those are all my four answers from 0 to 360. Okay, so here's another example. Here we're kind of, here because we don't equal 0, here we want to distribute this cotangent to both of these. So we get 2 cotangent squared x plus 3 times cotangent x. And then if we subtract 1 on both sides, we get negative 1 equals 0. So now it looks like a quadratic. So now we can go ahead and factor this. You could substitute u if you wanted to. 3u minus 1. Factor this. This is cab, so negative 1 because our a is 1, so that's really nice. Our b is 3. So what are the factors of negative 1 that add up to 3? Well, that's not possible, right? So here we'd have to do like quadratic formula. So negative b plus or minus the square root of b squared, so that's 9 minus 4 times a. 4, our a is 1, so that's negative 4. And then times our c, so that's positive 4. And then all over 2 times a's, which is 2. So then our u would equal negative 3 plus or minus the square root of 13 all over 2. And then we can go ahead and put that into our calculator and approximate it. So u is equal to negative 3.303, and then the negative 3 plus the square root of 13 over 2 would be u is equal to 0.303. Okay, so then we can substitute in cotangent, because that's what it was, right? So cotangent of x is equal to negative 3.303, and cotangent of x is equal to, so here I'm going to have to use my calculator, 0.303. So here I use my calculator on this one. And so on my calculator, which you'll see in the next video, is I want to do, when I do the inverse, so cotangent inverse of negative 3.303 equals x. So when I do this, I'm actually going to flip, because my angle doesn't flip when I'm looking at cotangent of theta equals 1 over tan of theta. So my angle doesn't flip, right? Theta is still theta, but my answer does. If cotangent of theta is 3/4, then tangent would be 4/3, right? I flip my answer, so this is the answer that I'm going to flip. So 1 over negative 3.303 of tangent, of inverse tangent. And that's going to give me my x. So I type that in my calculator, and because that is negative, so because I get a negative answer here of negative 0.294, I need to add pi to that. Alright, so I add pi to that, and I get approximately 2.84. So there's my answer to that. And then if I add another pi to that, I would get another answer. And this problem, they want all solutions. So say here's my answer, right? Somewhere up here. Cotangent's positive, right? Or here I get a negative 0.0294, or not, I get a negative 3.303 is what I get right here, negative 3.303, right? Well, if I add 180 degrees to that, right? If I was from 0 to 2 pi, then I would add another pi to this, 2.84, and I would get my second answer. But we want to keep on rotating. So every 180 degrees, or every pi, I'm going to get the same answer. So if I just add 2 pi, or not 2 pi n, just a pi n. Right, so if I just add pi n, I will keep on rotating. Or I could just add pi to this answer, 2.84, and get my second answer. And then just add 2 pi n to both of those, and they would be all my answers. But all I have to do, this is a little shortcut, so that would be all my solutions on this part of the equation. And then on the 0.303, I would do the same process, and then I would go ahead and add so I'd get approximately 1.277, and then I would add a pi n to that. And so those are all my answers. Okay, so here's a couple of practice problems, number 21 and 53 on page 696. Here's number 21. And so on these right now, they'll tell you to solve, from 0 to 2 pi, but they won't really tell you like which kind of method, right? So you kind of have to look at it, and so whenever you have a squared, you might think about factoring, right? Or you might want to think about quadratic. Right, so you could try factoring first real quick, move stuff to one side, see if you can factor out. But if you're still left with, 2 trig functions in there, then you might want to think about cabbing it. And most of the time when you have this kind of squared, you want to do that. So if we move everything to one side, we get 0 equals 2 sine. I added 2 sine squared x to both sides, because then they're all positive, right? I'd rather deal with positives. Okay, and then we can go ahead and factor this, right? We could use u, right? 2 times u squared plus 3 times u plus 1. Now I do have an a this time, so that means when I find my two numbers here, I need to divide those by my a. So this is 2, this is 3, so that's 2 times 1, and 2 plus 1 is 3. So my numbers are u plus 2 times u plus 1, but now I have to divide by my a, which is 2. And so we have u plus 1 equals 0, and u plus 1/2 equals 0. So u equals -1, u equals -1/2. Now we can substitute what u is. That is sine of x. X equals -1/2. Again, -1/2. So we're looking at a reference angle of 30 degrees. Negative would be below, so that's at 210, which is 7 pi sixth, and at 300, or 330, sorry, which is, so I might have got an answer wrong on another video, maybe. I'm thinking about this, 11 pi sixth, which is 330. I might have put 300, maybe. I think I did on a different video. So it should be 330. Maybe it was the first video, section 6, sorry. -1 sine. Sine is positive up here, +1, so down here, that's at 270, which is 3/2 pi. So those are my answers for x, all three of those. So here's number 53. We can go ahead and distribute, and then subtract 1 on both sides. So we get 3 sine x squared x minus sine x, and minus 1 equals 0. We can go ahead and factor this now. We do have an a, right? So, and then we have a middle of -1. So this is not going to work out, right? Because -3, all we got is 3 and 1, right? So we can't subtract them anyway to get 1, so we have to do Pythagorean theorem. Or not Pythagorean theorem, sorry. Quadratic formula, sorry. So -b, so that's a +1, plus or minus the square root of b squared, which is 1, minus 4 times a, so that's -12, times the -1 is a +12. So we get root 13 again, and all over this time is 6. So that's what sine of x equals. So sine of x will equal this. So I would want to put that into my calculator. And then all over 6. So I put that in my calculator, and I'm going to do sine inverse of that answer, whatever that is, into my calculator. And so I should get approximately, let's see here, 0.8751 for one answer, 8751 for one answer, and 2.2665 for another, and then also we get 3.5908. So here, when we type these in here, so when we type this in, we'll get, when we do the positive, we get this one, and then, so my answer is like something right here. Well, the difference, these usually have the same height, right? So this distance is pi halves. Just like tangent is 180, so I do pi halves, so I add pi halves to this, and that's where I get the 2.2665. Same thing when I do the 1 minus the square root of 13 all over 6, I get this answer, and then because that answer is say right here, then I can add a pi halves to that, and I also get that same answer. So that's how I get the 4 answers. Okay, so that's it for this one.